Hello, welcome to our presentation. We are Group 8 and my name is Bohyun Kim. In this video, we are going to show you how successfully we reverse engineer the main database interactions in Seamless. Let's get it started. The application we have chosen for this project is Seamless. Seamless provides online and mobile food ordering services. It offers the easiest way to order food for delivery or takeout. With Seamless, customers can place their food orders more efficiently, conveniently, and accurately without going through any frustrations that may occur on the phone or in in-person orders. Seamless was founded in 1999 as a web-based system for companies to order food from restaurants and caterers. Then in 2013, Seamless merged with Grubhub, a leading online and mobile platform for restaurant pickup and delivery orders. This merger created a vast improvement in their business. Seamless now currently partners with over 12,000 restaurants, serves over 4,000 companies, and has over 2 million members worldwide. At Seamless, they focus on providing value to both restaurants and diners through their two-sided network. They make the ordering process more accessible, accurate, quicker, and simpler for diners. Also, they provide restaurants with more chances for receiving orders and help them improve the efficiency of serving food. Seamless allows their customers to use their service anytime, anywhere. Their website is available for both Windows and Mac OS environments. And their application supports different technical platforms such as iPhone, iPad, and Android. For the scope of our project, we prioritized each database requirement by importance. We implemented only the following 3 requirements with the most priority to our database model. Customers can place orders to local restaurants. Customers can make payments for their orders. And customers can choose to have their food delivered or picked up. So based on these ideal requirements, we create our conceptual model, logical model, and physical model for the database.
Hi, my name is Kara, and I will present the second part. So, as shown in the diagram, we are exploring the relationship between customers and the restaurant. Other entities and attributes move around this core relationship. Customers have their personal information and payment method. Restaurants offer different menu items and options to get food, including delivery or pickup. With this customer section, one of the features of our conceptual model is that there is a relationship between customer and payment method. Customer pays their food order by payment method, which have 2 subtypes: PayPal and credit card, respectively. One or more unique attributes of the customer is disjoint with Seamless Plus and non-Seamless Plus members. Another interesting component with the restaurant part is that the restaurant usually offers 2 options to get food, including pick up or deliver. It indicates which option would be more popular with customers. So next page is participation. We have total participation and partial participation. For the total participation, we have customer and order and a restaurant. For the partial participation part, we have receiving option, either pickup or delivery, and menu items. Receiving option and menu item must be associated with an order and a restaurant respectively. Next part is a key entity. When we built the conceptual model, the phone number and the restaurant ID were defined as key attributes in each section with the phone number and their personal information. Each customer uses it to register a seamless account and money account and order food from the restaurant as well. The restaurant ID is identified with unique attributes to the restaurant. It's also related to menu items in this restaurant because item ID contains a part of the restaurant ID, such as abbreviation of the restaurant name and the postal code. So next page is logical model. We transfer conceptual model to the logical model, and it shows how the customer table and the restaurant table play an important role in the database. The phone number and the restaurant ID are primary keys for the customer and the restaurant section, respectively. Other tables have their own foreign keys to connect with two main tables, the customer and the restaurant. Our largest table that records the most information. For example, name, street, city, postal code is the customer and the restaurant because they are components in seamless business. In addition to analyzing customer profiles through this identity information, the organizational goal would be understand which locations can be more popular with customers.
My name is Zhongning Yang. I will illustrate our physical model. As you see, we made 7 main tables: customer, review, payment information, order line, delivery, restaurant, and menu item respectively. Obviously in the customer and restaurant table, phone number and restaurant ID are primary keys. In the payment information, order line and menu item tables, payment ID, order ID, and item ID became the primary keys. It is noticeable that in the delivery table, order ID, phone number, and restaurant ID are combined as the primary keys. Furthermore, in the review table, the phone number is only one foreign key to connect with the customer table. Honestly, in our ideal tables and creative tables, the delivery is only different points. I mean, in the ideal table, it should include the delivery table because in our real life, most customers choose delivery service to get their food, which will save their time. However, we didn't include the delivery table in our creative table. The main reason is the delivery service is usually the third-party service. It indicates we need to insert another relation between the customer and restaurant, which will make our database more complicated than what we expect. In the main goal of our project report, we want to show the main relationship between the customer and restaurant in seamless. So we believe that in the commodity database, it is necessary to have this, delivery relationship. So it's going to be what we develop in the future. Now move on some sample data we made. As you can see, we just show a small part of customer table. Actually, there are 15 rows we made. The next table we are showing here is restaurant table with 8 rows we made. You probably know one of a restaurant from the table because we find it out from Google Map and they are in Utah. Another example is menu item. There's an interesting point I need to explain for you. Check out is item ID we made. In our idea, the item ID of menu item should be included with the abbreviation of the restaurant name, restaurant ID, and its postal code. For example, in the first row, which is item ID, capital LH means Log Haven Restaurant. 101, it is, restaurant ID. And A for 109, it is postal code. and 01 just a number. So we think these elements will make unique ID for each item. So when users are using the database, they can find out many useful information. For instance, we are displaying which delivery option, like delivery or pickup service, will take average longer time. Obviously, the delivery is more popular with customer, which also takes much shorter time. Furthermore, user can find out the money cost for each phone number. In this case, the phone number 253-904-7875 spend the highest money. And note, there's no here. If user want to know more information such as the customer name of this phone number, it's really easy to find out because phone number is only one primary key in the customer table. It is listing all information about each customer.
Thank you, Bruce. Now let us discuss the progress for the selected requirements. As discussed earlier, our focus for this project was placed on customers' activities to place orders, make payment, and select how to receive their orders. Among the 7 specific tables that we selected, we have completed ones for customers to register for the services, restaurants to launch operations on the platform, and menu items to be linked to restaurants, customers, and outgoing processes for the ordered meals. Adding more data for each table remains as an ongoing progress. There were no requirements that had to be canceled in our project. And finally, we chose not to initiate requirements for customers' membership status and participation by drivers, mainly because our requirements were centered at the customer's activities for placing orders, making payments, and choosing a way to receive what they've ordered. Before completing our presentation, we would like to add our own discussion as a team on how Seamless could maximize their revenue in relation to the database design. Through this project, we learned there are mainly 2 revenue generation methods, one from monthly Seamless Plus membership fees, and 2 from per order charges to restaurants for the use of the platform. For membership fees, Seamless could increase the fee rate or increase the number of Plus members to maximize revenue. This was in our not initiated requirements, but we believe Seamless could link the membership status and order line tables to provide Plus members' orders priorities if ordered at the same time with non-members, making this an advantage and motivation to sign up for the membership. With the per order charges to restaurant partners, Seamless could maximize revenue by either increasing the per order charge rate or increase the number of orders that each restaurant partner can accommodate. To increase the number of orders to be handled, we believe Seamless can add more data such as meal preparation time to be used to streamline kitchen operations, as well as to display menu items in order of easy-to-process meals in each food category. Lastly, Seamless could link data for weather, temperature, busy hours, day of week, and holidays to provide demand forecast to restaurant partners as well as drivers as a competitive advantage to differentiate themselves in the industry. In conclusion, we confirmed that the database we created align with the value that Seamless provides to both diners and restaurant partners. We've witnessed that the demand for online food ordering business increased in the rise of pandemic. As more companies attempt to join this industry, companies will be required to seek ways to differentiate themselves among their competitors. This project helped us see that databases play an essential part
not only to support but also to expand their customer and partner bases. Thank you very much for your attention, and please reach us anytime for your questions. Thank you.